Here's some more problems that have to do with factoring and just manipulation of specific algebraic principles to allow us to solve some problems. This is a good one that comes up quite a bit, and it says find 1 over a plus 1 over b if a plus b equals 12 and a times b equals 4. Well, when you are doing this one, you might be tempted to try to solve the algebraic system of equations, a times b equals 4 and a plus b equals 12. And it is possible to solve this. However, it's very difficult to solve it. A much easier way to do it is to start at the end, 1 over a plus 1 over b, and solve backwards. Well, if you add 1 over a plus 1 over b, you get 1 over a plus 1 over b is the same as, well, common denominator would be a over b. So you'd get a over ab, or b over ab, plus a over ab, which we can write as a plus b over ab. So by doing some algebraic manipulations, you can get to a point where we can easily find the solution to this just by plugging in what we know. We know that a plus b equals 12, and we know ab equals 4. Well, that means that instead of a plus b, we're going to write 12. Instead of a times b, we're going to write 4. And so that solution is 3. Another way you might see this problem is the sum of two numbers is 12, the product of the two numbers is 4. What is the sum of their reciprocals? Okay, another type of problem. This is the one where you use the most intricate factoring, or really actually you're doing the opposite of factoring, just multiplying it out. And that is, find x to the 6th plus 1 over x to the 6th if x plus 1 over x equals 4. Again, you can find the solution to this for x and then take the cube root, then take x to the 6th power. However, it gets very, very, very messy to try to do that. Instead, what we want to do is we want to understand that this right here, this x plus 1 over x, squares very nicely. Because when you square both sides of this equation, which is a very common technique, you're going to get, well, x plus 1 over x squared. Remember, it's the first term squared, so x squared, plus the product of the two terms, which is x times 1 over x, which just equals x over x, or 1. And you always multiply that by 2, so you just get 2 times 1, plus 1 over x squared. And then whenever you square one side of the equation, you square the other, and you get 16. And so now we're sitting there looking at x squared plus 1 over x squared equals 14. So if I know x plus 1 over x equals something, I can very easily find out what x squared plus 1 over x squared equals. Well, using the same type of logic, I can find out what x to the 6th plus 1 over x to the 6th is. And you can do that by cubing this. Now, the other way to do it is just to square it and then multiply, just keep multiplying by this, which is the way we're going to do it. And so I'm going to square both sides of this. And that gives me, again, first term squared, so that's x to the 4th. Multiply these together, you get 1 times 2. Square this one, you get 1 over x to the 4th. 14 squared just equals 196. And so I'm sitting there with x to the 4th plus 1 over x to the 4th, so I'm getting close, equals 196. Now at this point, what you can figure out is, if I wanted x to the 5th plus 1 over x to the 5th, I would just multiply by this, which means I'd multiply both sides by one side by this and one side by 4. But what I'm going to do is I'm going to multiply the left side, so x to the 4th plus 1 over x to the 4th, by, I need to get x to the 6th, so I need to multiply by x squared plus 1 over x squared to finish my cubing. And then the right side, I just need to multiply the 196 times 14. Okay, since x squared plus 1 over x squared equals 14. Then, when I multiply this out, well, this times this gives me the x to the 6th like I'd hoped. X to the 4th plus 1 over x squared, well, that gives me x squared. And then 1 over x to the 4th times x squared, that gives me 1 over x squared. And 1 over x to the 4th times 1 over x squared equals 1 over x to the 6th. And then I multiply 196 times 14, and I get 2,744. However, you might look at this and say, well, Mr. Tormel, and that doesn't give you the right answer. It gives you x to the 6th plus 1 over x to the 6th, but you have this right here. But we know that that equals 14. So if I subtract 14 from both sides, I find out that x to the 6th plus 1 over x to the 6th equals 2730. So by squaring it and then substituting in when I know values, I can very easily find out the answer to that problem. Okay, the next trick that we want to learn is called Simon's favorite factoring trick. And this has some different applications, but the basis of this trick is adding and subtracting something to use factor by grouping. Okay, this is always used when you're trying to solve an equation. A lot of times what's going to happen is you're going to have something like this. You're going to have, let's say, xy minus 6x minus or plus 6y equals 4. And you're asked to solve this equation and find something out about this equation. Well, what you're going to do is you're going to try to factor that left side. Well, if you notice, these two have something in common. They both have an x in it. Or you could do the 6y and the y, and they have something in common. They both have a y. So if I factor out an x, I'm left with y minus 6. Well, to factor by grouping, I need to take something with the 6y that's going to give me a y minus 6. Well, to do that, I need a negative 36, because when I factor the 6 out, that's going to give me y minus 6. But if you add something to one side of an equation, you have to subtract it, or you have to add it to the other side of an equation too. Now I can factor, and you can see that now I can use factor by grouping, so I get x plus 6 by factor by grouping, because I'm factoring out the y minus 6 out of both those, equals negative 32. I can find all the ordered pairs that would make this true, and we'll talk about that in the next problem. Okay, but the key here is the subtracting 36 from both sides allows us to factor that problem in one that wasn't factorable otherwise. We know that for this particular problem is where this is applied most often, but there are other applications to this as well. How many ordered pairs integers satisfy this? You can really start beat your head over a wall for a while trying to just think of them. Instead, what you do is you use Simon's favorite factoring trick. Multiply through by the denominators, which is 4xy. That's going to give you 4y. So we're multiplying all this by 4xy. Plus 4x equals xy. If you subtract the xy, you get 4y plus 4x minus xy equals 0. And we want to solve this equation. Well, to solve an equation, we like to factor. Well, again, you see how you can factor an x out of this. So you're left with 4y plus x times 4 minus y equals 0. Well, it's a little harder because I need a 4 minus y. If you notice, I can easily factor 4 out of here, but that gives me a positive y. If I factor out a negative 4, then that gives me a negative y like I need. So what I need here with it is a negative 16. So I need to subtract 16 from both sides. Because now when I factor out a negative 4, I end up with 4 minus y plus x times 4 minus y equals negative 16. And that's going to give me 4 minus y times, negative 4 plus x is x minus 4 equals negative 16. I don't like the negative 16, so I'm going to multiply both sides by negative 1, which will flip this one around. Right? If you multiply 4 minus y times negative 1, it becomes y minus 4. So we get y minus 4 times x minus 4 equals 16. Well, if you're looking, we want integers x and y. Well, it turns out, how many different factor pairs are there of 16? If you know how to find that, you're going to find out that you can have 1 and 16, 2 and 8, and 4 and 4. Well, I can get 1 and 16 very easily by making y 5 and x 20, and that would be 1. So y equals 5, x equals 20 would work, and then vice versa. And so it actually turns out that for each one of these pairs, you get 2 of them. For the 4, 4, there's only one way to do it, right, if x and y are both 8. However, because this said integers and not positive integers, you got to consider the negatives as well. And so you actually are 2 for each of the negatives. And so you end up with 4 plus 2 equals 10. So there are actually 10 different values of x and y that solve this equation. That's Simon's favorite factoring trick, and you'll have an example of this, and you can go through and try to figure it out on your own.